Let's talk about multiplying and dividing numbers in scientific notation. We'll do a couple of examples just to kind of help you get it figured out. So first example, directions say simplify, write your answer in scientific notation. So what I see is two things being multiplied together. They happen to be two numbers written in scientific notation. 9 times 10 to the sixth and 3 times 10 to the fifth are being multiplied together. When you see two sets of parentheses sitting next to each other, you can assume that you are to multiply. So really what we have here is quite a lot of multiplication happening. 9 is being multiplied with this, 3 is being multiplied with this. We also have multiplication here. So you could rewrite it just so that you can see all of that multiplication happening. And then what's nice about multiplication is it doesn't matter what order you multiply in. You can multiply in any order you want, and you'll get the same result every time. So I'd like to regroup these so that I'm multiplying my leading numbers together, and then I'm going to combine the powers of 10. So when I multiply 9 times 3, I get 27. We're going to now multiply that with all of these powers of 10. 10 to the sixth, remember, is 10 being multiplied by itself 6 times. And 10 to the fifth is 10 being multiplied by itself 5 times. So now what we have is 10 to the 11th power. Remember, we add exponents when we're multiplying and the bases are the same. So 6 tens here, 5 more here, we have 11 tens altogether. Now remember, the directions do say to write your answer in scientific notation. And although this does look like it might be in scientific notation, remember one of the primary things about scientific notation is you can only have one number to the left of the decimal, and we happen to have 2. The decimal's sitting right there, and we have a 2 and a 7 in front of the decimal. So we need to adjust that. And when we do that, you have to also recognize that you have moved the decimal one place, which will change the exponent on your power of 10. So right now, this number, if we were to follow this set of directions, would have 27 followed by 11 empty spaces, which would be 11 zeros. And then we have to move the decimal from here so that it's sitting right here. So we are moving it one extra spot. Sometimes it's hard to know whether you're going to be changing this to a 10 because you're changing it by 1, or if it's going to go up to a 12. So if you need to, write it out and see what it is following this set of directions, and then count how many spaces you're going to be moving it to put it into scientific notation. In this case, we're moving it 12 times. We have a large number, so our exponent is positive. So when you multiply 9 times 10 to the sixth and 3 times 10 to the fifth, you will get 2.7 times 10 to the 12th. Okay, example 2, same directions. And now we have a number written in scientific notation that is being raised to the power of 2. Couple ways you can look at it. You can apply this power of 2 to the 8, and you can apply the power of 2 to the 10 to the 4th, which would give you 8 squared times 10 to the 8th. You have 2 sets of 10 to the 4th. And then 8 squared is 64. And we have 64 times 10 to the 8th, which is not in scientific notation. We have 2 digits to the left of the decimal, so we need to move it. And this ends up being very similar to the problem we just did. This number following these directions would be 64 followed by 8 empty spaces, which would be filled with zeros. And then to put this into scientific notation, we move the decimal so that it's sitting right behind the 6. And that means we had to move it 9 times, and that makes 10 to the 9th power. So when you're squaring, you can apply the square to each separate piece, remembering your rules for exponents. Don't forget to change your answer into scientific notation by moving the decimal so that you only have one digit to the left of it every time. All right, so example 3 is a little different than the last one. The last one we were raising it to a power. Now we're just multiplying the whole thing by 7. So it might be helpful to write it using this form instead of the parentheses, because you want to remember that we're not distributing here. This is not an addition sign. This is a multiplication sign. And so this is just one long multiplication problem. We have 7 times 9 times 10 to the negative 3. We can go ahead and multiply 7 times 9, which gives us 63. We bring down the 10 to the negative 3. And we need to move the decimal for sure. It's sitting right here, and we have 2 digits to the left of it, and we're supposed to only have 1 digit to the left of it. So we're going to move it 1 space. We have to determine whether this is going to change to a -4 or a -2. It's definitely going to change by 1 because we're moving our decimal 1 space. Instead of trying to remember some little shortcut or nice little trick, sometimes it's just better to write the number in standard form so that you know exactly what it represents, and then you can write it as a scientific notation number. So currently we have 63 with the decimal sitting right here. We need to move it 3 places to create a small number. I know it's a small number because my exponent is negative. And so I'm going to move it this direction because going this direction makes a small number. If I go this direction, I'm going to be creating a large number, which is not what this is telling me. This says we're going to have a small number. So 1, 2, 3 spaces, fill it in with a 0. So what it ends up being is 0.063. Now to write it in scientific notation so that I only have 1 digit to the left of the 0 or to the left of the decimal, move it right there. It becomes 6.3 times 10 to the negative 2. We've moved it 2 places, and this is a small number, so our exponent is negative. So when you have a number being multiplied out front, this is not addition. Do not distribute. Recognize it's one long multiplication problem. Multiply your regular numbers, bring down your power of 10, and make sure you're in scientific notation by moving the decimal if you need to. All right, so we've had 3 examples involving multiplication of some sort. Now let's talk about division. We have 6 times 10 to the 8th power being divided by 2 times 10 to the 5th power. You can break this into pieces and focus just on your regular numbers and focus separately on your powers of 10, kind of like we did with the multiplication. We took care of the regular number, we took care of the powers of 10. So 6 divided by 2, that's nice, it's just 3. We have 10 to the 8th in the numerator, 10 to the 5th in the denominator. If we write it out the long way, we've got 8 tens in our numerator. And in the denominator, we have 5 tens that are going to cancel out 5 of these tens in the numerator. They cancel them out because we have 5 sets of 10 over 10, and 10 over 10 equals 1. So all of these simplify down to 1, and we're left with 10 to the 3rd power in our numerator. Hopefully you recall or recognize that shortcut from our exponents unit where you can subtract the exponents when you are dividing, because these 5 tens are going to pair up with 5 of these tens and simplify down to 1, so they're gone, and we're left with just 3 tens in the numerator. So when you divide, separate the numbers and the powers of 10. Divide here. This is not subtraction. This is division. 6 divided by 2 gives me 3. And then we get our power of 10. It's in scientific notation, so we are done. All right, let's look at one that has some negative powers just to make sure that's all nice and clear for you. Similar setup. we need to focus on our numbers that have no powers separately from our powers of 10. 8 divided by 4 gives us 2. And here we have 10 eighths in the numerator, and we have 10 to the negative 7 in the denominator, which means it really belongs in the numerator. So we are going to be putting an additional 7 tens in the numerator to give us 10 to the 15th. The other thing you can do is recognize the shortcut. If we need to do 8 minus negative 7, when you have subtracting a negative number, change it to adding the opposite, and again, we get 10 to the 15th. So either way you look at it, if you like to think of these as being moved up to the numerator and they're joining the 8 that are already there, it gives you 15, or you can use the shortcut and subtract, and you still get a positive 15. Again, our number's already in scientific notation, so no need to move the decimal. All right, one last example. 1.5 times 10 to the 7th, definitely a number in scientific notation, being divided by 3. So we don't need to worry about the 10 to the 7th. It's just going to tag along for now. This is the division that we need to take care of. 1.5 divided by 3, you might recognize 1.5 is half of 3. So when we do this, it's going to equal 1/2, and as a decimal, 1/2 is 0.5. Bring down the 10 to the 7th, and we have a number that is not in scientific notation. We have a 0 to the left of the decimal. With scientific notation, it can't be a 0 to the left of the decimal. 1 digit to the left of the decimal, yes, but not 0. So that means we're going to have to move this decimal 1 space over, which means this is either going to become a 6 or an 8, and we have to determine that. So if we just follow the directions that are given here, where we have 0.5 times 10 to the 7th, we're moving the decimal 7 times. It's positive, so we're making a big number. To make a big number, we go this direction. If we move 7 spaces this way, we are making a small number, and that is not what this is telling us. Positive exponent, big number. So move it over 7 times. 1, 2, 3, 4, 5, 6, 7. Fill in all those empty spaces with zeros, and we have 5 million. All right, so now to take that number and put it into scientific notation, we're going to move our decimal back, but this time we only move it back 6 spaces. So this is going to become 5 times 10 to the positive 6, because this is a large number. So when dividing with powers of 10 or scientific notation, and you have a number that is not in scientific notation, match those up and let the power of 10 tag along. Make sure your result is in scientific notation, and you're done.